The next thing for you to know about programming is a little bit of the history of programming and how programs have been written. We've written programs in different ways. The paradigms by which we write programs have changed over time. What the heck does that mean? Well, here's the word paradigms. It's paradigm. Paradigm, that's what that word is. It's not a pair of quarters. It's not a pair of nickels. It's a paradigm. And what is a paradigm? A paradigm is a typical example or pattern of something, a model, a set of linguistic items that form mutually exclusive choices, in particular syntactic roles. I think I'm going to stick with this right here. It's a model, it's a pattern, right? So we've had models, different models or different patterns, different ways of writing programs throughout time, and they've kind of improved. And so we're going to talk about three. We're just kind of looking at the history of how did we go about writing programs, how did programming evolve over time, and the way that we write programs, how did that evolve over time? So we've had three main programming paradigms. There's actually a lot of them out there, but the three that I want you to know about, the three main ones, are spaghetti code, procedural structured programming, and object-oriented programming. These are like three different ways of writing programs that have evolved over time. So when I was a kid, I was in junior high, and we were writing programs using spaghetti code. And spaghetti code had a lot of go-to statements in it. And so all the code was on one page. And if you wanted something else to happen, you'd jump down the line. You'd go to line 200, and you run the code at line 200. And then if you needed something else to happen, you'd jump to line 2000. And all the code was on one page, and it was really difficult to figure out what was going on after a while because you had all these go-to statements jumping you all over the place. And following the lines of logic was kind of like trying to follow a noodle in a spaghetti bowl. Like, where is this line of logic going? And you would just kind of get lost. And so they called it spaghetti code. And I imagine spaghetti code also sort of evolved, that phrase sort of evolved, because back in the day, right, this was how computers were programmed, and it looked like a bunch of spaghetti. Had all these cables that you plug in to make circuits and to make paths, and if this happened, then it'd fire these circuits over here, and even today, right, like, imagine trying to follow a certain wire and figure out where it's going, or this example here. I mean, that's not literally spaghetti code right there, but you could see the analogy. This is where computers came from. This is how computers used to be programmed right here, was with those cables. And so when we actually started writing code, the code was just on one sheet of paper with all these go-to statements, and we called it spaghetti code, spaghetti code. So that's just the first paradigm, the first way that programs were being written. And it was hard to follow the logic, logic. So then we came up with structured programming, which is also, I think of these two as pretty much the same. But we're going to start out with structured programming. And structured programming said, instead of having everything in one big page, all this code on one page, let's break it down into little blocks, little sequences. And so structured programming is a programming paradigm aimed to improving quality, clarity, and development time of computer program by making extensive use of subroutines, block structures, and for and while loops, in contrast to using simple tests and jumps such as the go-to statement, which could lead to spaghetti code, which is both difficult to follow and to maintain. And so with structured programming, we really start to structure our code more. We'd have little blocks of code, subroutines, which would run, okay, go get this little piece of code and then run it if this happens. And we had a lot more of that flow control where we had, while loops, or these down here, conditions, right? So we had the conditions, the if-then statements, we had the loops, right? The loops, yeah, iterations is what we were calling them earlier. So that was structured programming. And then came along procedural programming. Again, I think about structured programming, procedural programming is the same, but procedural programming can sometimes be used as a synonym for imperative programming, specifying the steps a program must take to reach the desired state, but also can refer to, as in this article, to a programming paradigm derived from structured programming based upon the concept of a procedural call. So, here we were really starting to think about these little things, these subroutines, right? Subroutines, procedures, which we could call, right? So it's really kind of based upon actions. If the user does this, then run this thing over here. If the user does that, then run this piece of code over there. And so we started to break all of our code out into little procedures. Thus it was called procedural programming. And then this new paradigm came along, object-oriented programming. What is object-oriented programming? And object-oriented programming went from an action-based, like, okay, we're going to respond with procedures, actions based upon what the user is doing. So a user takes an action, and we're going to give them this procedure. That was procedural programming. And it was sort of action-based, right? Like the user does something. I move this scroll bar, and then the action, because of this action, we run the procedure of adjusting the window up and down. That little chunk of code gets called. That was procedural programming, is based on actions. And object-oriented programming also has that in there. But with object-oriented programming, what was also included was, let's start looking at the objects which we're using, right? Instead of looking at the actions completely and only that the user's doing and having procedures to respond to those actions, let's also look at the objects which we're putting out there and look at how those objects have a lot of similarities. So what am I talking about? So let's say I wanted to create a button. And here in this little video, you can see I've put 3 buttons on a form, and I'll show you where this video is in a second. And this is an object. This button is an object. As a matter of fact, over here I have a whole bunch of objects I could draw from. And so I could just drag these objects out. And each time I drag an object out, I don't have to write the code for it. And the code for a button is written one time. It's an object. And then that object could also, right, be thought of as a class. And so each button could be modified. And I can modify, and each button also has a very distinct thing that it does, right? So I can modify the variables or the properties of the button. I can come over here and I can change the labels on the button. And if we watch this video for a second, I'm going to change the color here right now, one moment, right? I'm changing the color of the text. The text just changed, but now let's see if I change the other color, the back color. Ah, look, it just got clear. How awesome is that? And there, I just changed the back color of the button. And I'm changing the back color of the button again, right there. So each object has variables, right, or properties which I could change about it. And the objects also have methods, meaning they do certain things. And so buttons can be clicked, and buttons, are an object that have certain properties. Just like, there could be like an object called a car or a vehicle. We could have an object called a vehicle, and we'd call it the vehicle class, right? And then we could have instances of that class. We could have truck, we could have race car, we could have, different instances of that class. So object-oriented programming is a programming language model organized around objects rather than actions, and data rather than logic. Historically, a program has been viewed as a logical procedure that takes input data, processes it, and produces output of data. That would be procedural. The programming challenge was seen as how to write the logic, not how to define the data. Object-oriented programming takes the view that what we really care about are the objects we want to manipulate rather than the logic required to manipulate them. Examples of objects range from human beings to buildings and floors, down to little widgets on a computer desktop, such as buttons and scroll bars. Right? So those would be objects. The first step in object-oriented programming is to identify all the objects the programmer wants to manipulate and how they relate to each other, an exercise known as data modeling. Once an object has been identified, it is generalized as a class of objects, which defines the kind of data it contains and any logic sequences that can manipulate it. Each distinct logic sequence is known as a method. Objects communicate with well-defined interfaces called messages. So objects also have variables which you can change, or properties which you can change, and objects have things they do, which is known as a method. So if I had the vehicle class as an object, right, some of the methods or some of the things the vehicle class could do would be, go forward, go backwards, have doors that open, have doors that close, have headlights, right? And so, I could adjust all of those different properties or variables about, well, I could adjust like the properties, variables of the vehicle, like color and things like that, but the methods, the things that they do, would apply to all vehicles. So anytime I created an instance of a vehicle, I know this is kind of like, what? Yeah, they would, they would inherit those methods, those things that they do. All right, so, the main thing to know is we went from this spaghetti code deal where it was very unstructured, and then we got structured programming, procedural programming, which was based upon running little modules, procedures when somebody did something, so it's based upon actions. And then we went to object-oriented programming, which was more based upon also, including the structured procedural aspects, but really focusing a little bit also from creating objects in different classes. So we only had to write the code for button once, and then we just pull that button out. That's basically it. So I didn't show you the Visual Basic here, but this is a really good example of object-oriented programming, and I talk about it in more detail. So if you go to YouTube and search for FCC CIT15 Visual Basic Project, you could see this is in my in-person class at the college. So if you're in that class, this is one of the assignments that we are doing at the time that I record this video, which might be different than if you're not watching this. If you're watching this at a different point in time, so make sure you look at the assignments page if you're in my college class. But this is a great example, nonetheless, of object-oriented programming and how we use objects to create a little program to run. But we also go back there and it has modules or little procedures that happen when certain actions occur, like when the button gets clicked. So those are paradigms of programming. Spaghetti code, where it kind of started out, procedural and structured programming, and object-oriented programming. And on this one, I should probably have structured in front of procedural. Just think about it in that order. There we go, a little bit about programming.